So the first is web search. In this problem, you have some query, some input query that you might input into Google, and you want to rank web pages based on the relevance to the query. And so query might be Apple computers, and you need to produce some information based on, and produce some web pages based on that query. And it's not exactly classification, because instead you're going to be ranking which of the web pages are the most relevant, and giving a ranking of all the web pages that you have, instead of just classifying which ones which ones are relevant and which ones aren't relevant. Because there's probably a lot of them that are relevant, and you want to instead rank them instead of just classify them. So the way that you can set this up is you'll have a feature vector. You'll have multiple feature vectors for each query. So if your query is X, then you'll make a feature vector for that contains both X and the web page. And it will produce some vector in your feature space having the input of both your query and a web page. And then if you have another web page, then you will also have a feature vector with input of your query and that new web page. So you're going to have a lot of different feature vectors, one for each pair of query and web page. And so you have your input X and your candidate Y, and the way you make your prediction is by choosing the web page Y that maximizes the weight vector times your feature vector of the query and the web page. And if it's wrong, if this produces a prediction that is incorrect, then you update your weight vector by taking the correct web page and the correct features of that web page, and you only have a single weight vector, so you are taking the correct web page and subtracting the incorrect web page. So you're making it the correct pair of query and web page and subtracting the incorrect pair. So what this would look like is you're actually going to make two different updates for this weight vector. So the correct pair is this, and the incorrect pair is f of xy. So you'll add f of xy star and subtract f of xy, and then you'll get your new weight vector right here. And that weight vector will do a better job of ranking the data. And then the other example that we can look at is apprenticeship. And in this case, you are learning to do actions, and you are learning from a teacher. So you can see this, you'll see this in your Project 6, but say you are Pac-Man and you want to learn how to play Pac-Man based on some teacher that can perform well and can perform what you want to do. So the candidates are state action pairs, and the correct actions are the actions that are taken by the expert or your teacher. And you have features defined over your state action pairs, and you have a score or an activation that is your weight vector dot product with your feature vector. So if you have an expert that is going in one direction in one state, and you want to be able to do just as well as that expert and act just like that expert, you try to copy what the expert does, and given the same state action pairs, you want to maximize, you want to pick the action that's most similar to what the expert does. And this is very different from reinforcement learning. So you actually don't even have to think about the rewards in this case. You just have one expert. You don't have to do minimax search or other searches. You just have some expert, and then you try and copy what that expert does. Any questions on how that works before we have a demo? So in this first case, so we're gonna show two training runs where we have a expert that learned according to minimax. So this expert is moving and it's trying to not die according to minimax search. And then we're gonna learn based on each step, each state and action, we're gonna learn some features according to, basically learn how this Pac-Man is acting. So, for example, at every time step, we'll see, okay, the expert is right here, and this is the state that it's in, and this is how it acts. And so therefore, when I see this state, I should act just like that, and I should update my weights based on how the expert is acting. So here's another training run. This Pac-Man is a more conservative Pac-Man. It's not picking up the power pellets. And so the weights that you're gonna learn are gonna be similar to that. So this expert's pretty good, as you can see. And then so you can see the weights right here. So the weight for close to food is positive. Close to scared ghost is 0 because it never got to that situation. Close to ghost is negative 0.72, so that's pretty high negative value. So it's gonna be penalizing. It's not gonna like being in states that are close to the ghost. The weight for the score is slightly high, and so on and so forth. So now we can see what the learned agent did from learning by watching those two examples. And it's just learning from the expert. So what it does is it learns to stay away from the ghosts and to like picking up food over time. And you can see just like because the expert didn't pick up the power pellets, this also learns to not pick up the power pellets. And it does pretty well. And then we could also look at another example of a different expert. So in this case, the expert is less conservative. It's going to go for the power pellets and try and eat the scared ghosts. So this expert's pretty good. And then we can see another example of this expert right here. So again, at every single time step, every single state action pair, you're learning weights for your feature vector, or weights for your weight vector, and looking at all the actions that it makes. This one's a lot more aggressive. And so the resulting weights here, close to food is positive, close to a scared ghost is also positive, so it learns that it wants to try and eat the scared ghosts. Close to a ghost is negative. Close to, your score is 1, so it learns that the score is very, very good in this case, and that and close to a pellet is less important than before, but still good. And so then this is what the learned apprentice Pac-Man does. So it learns to pick up pellets, and also that eating ghost is good, and it does pretty well. So it eats the ghosts, and it eats all the pellets successfully. Of course, you can also give it a different type of teacher. So if you give it a teacher that's very bad, and that's what it learns from, and it learns to just go straight to the ghost and die. And then give it another example, another teacher, then the result of what it learns is it learns to just go straight and die. And that's what it'll learn. So it basically learns just to copy the teacher and what sort of, what example the teacher provided. So any questions? And I think you'll actually be implementing this in your next project. Okay, so that's it. Next week we will be covering kernels and clustering.